Hello, I'm Haesoo Chung from Seoul National University. Today I'd like to present our work, High Dynamic Range Imaging of Dynamic Scenes with Saturation Compensation, but without explicit motion compensation. When we take pictures with a standard digital camera, resulting low dynamic range images are quite different with the real scene. High dynamic range imaging generates an HDRI image which has a broad dynamic range and thus closely resembles what humans see. Many methods utilize multi-exposure images to collect more information, but objects and camera motions easily introduce ghosting artifacts, and severely saturated areas provide little information. To deal with dynamic scenes, existing methods attempted to perform alignment. If three input images are given, they align the underexposed and overexposed image to the middle reference image, and then merge the aligned images into an HDR result. These approaches mostly focus on the sophisticated alignment and rather overlook the need to restore the saturated areas. In addition, they still suffer from artifacts when large motions exist. In our work, we reformulate the difficult image alignment problem into an easier brightness adjustment problem of the reference image to alleviate the ghosting artifacts. Also, we present a reconstruction strategy with explicit saturation compensation. In the proposed framework, first, a set of brightness adjustment networks generates well-aligned multi-exposure features, and then the coarse-to-fine merge and hallucination network integrates the aligned bracketed features and hallucinates details in saturated regions. So each BAN takes the reference and the differently exposed image and adjusts the exposure of the reference image while retaining its structure. Specifically, the BAN applies pixel-adaptive deformable convolutions to the reference feature. The well-aligned bracketed features are then fed to the merge and hallucination network. The coarse network first merges the features into the coarse HDR. In the fine network, an adaptive contextual attention layer performs saturation compensation. Our core idea is to find similar, valid content to replace the saturated parts properly. First, we construct a sample-specific saturation mask representing how saturated each pixel is. Then the adaptive contextual attention layer measures patchwise attention between the overexposed and well-exposed patches. Here is an example of a single query patch. We replaced the overexposed query patch with a combination of the well-exposed patches according to the estimated attention scores. Finally, the completion module generates the final result by replacing the saturated pixels of coarse HDR with the ones of fine HDR. When training, in addition to the reconstruction loss, we adopt a color loss to address the color shift problem. And also we use the BGG loss and total variation loss for realistic texture generation. We compared our results with other methods using the dataset constructed by Kalantari et al. Our method achieves the best performance in terms of all metrics and does not require any pre-alignment process. These are our qualitative results. Our method successfully reconstructs detailed texture even when saturations and large motions are present. Also, evaluations on the other dataset demonstrate our generalization ability. Thank you for your attention, and please check out the paper or the GitHub for further information.